Bromate ion comes up a lot. Bromate. Can you draw the Lewis structure of bromate? It's not so easy, but if we do, it's an expanded octet forming compound. Let me draw Lewis structure for bromate here. Br double O. The overall charge of this polyatomic anion, it's an anion, so that you could have something like sodium bromate. 보이니? Sodium bromate. Now, you've got two single bonded oxygens that are negatively charged, and bromine itself is going to be positively charged, which is why overall it's one negative. Now, this guy can be oxidized, can be reduced. Here, bromate act as oxidizing agent. Okay, so it's reduced in acidic conditions to form bromide ions. So BrO3 minus turns into Br minus. Deduce half equations for this reduction reaction. We're never taught this. It's neither in the data booklet. Bromate cannot be found here. Bromate, iodate, these are not found here. You have to deduce them. How do you deduce them? What was our first ever class on? It was on balancing half equation. You're going to do exactly the same here. We're given the information that BrO2, BrO3 minus somehow turns into Br minus. What are we going to do here? So, 첫 번째, make sure we've got one bromine on either side. Second, make sure we've got the same number of oxygens. 3 oxygens, which means we're going to add 3 water. Now, let's make sure we've got the same number of hydrogens. Let's add 6 protons. Now, what are we going to do? We're going to add electrons, probably to the reactant side, because we are talking about a reduction half equation, but also because we've got a lot of positive charge on the left, don't we? So we want to reduce the positive charge. But by how much? We've got 1 minus on the right. We've got 1 minus on the left and 6 plus. So we need to add 6 electrons. Do you agree? Now, we've worked out the reduction potential of bromate. And with that information, we need to combine that with the reduction of iron.